Welcome back to Speller Tutorial Services. Today we're going to continue with a second example of proof by induction. First thing we're going to do is to prove that S sub 1 is true. When we talk about S sub 1, I've taken the value of n and given it a value of 1, and I know that my first term here should be a 3. So 3 is equal to 1 times 1 plus 5 divided by 2. All I did was substitute the value of 1 in for these n's. 5 plus 1 is 6, and 6 times 1 is 6. So now I have 6 divided by 2, and that does in fact come out to be 3. Next thing I need to do is assume that S sub k is true, and also that S sub k plus 1 is true. So what I need to do is to take this series here, and I'm going to express it in terms of k. So 3 plus 4 plus 5, the ellipse, and instead of writing n, I'm going to actually change that n to a k, and I do that same thing for the expression here on the other side of the equal sign. The next step is to find S sub k plus 1. So basically I take this first series here, rewrite it, and I'm actually going to find the term after this last term. So I rewrite this k plus 2 term, and now I'm going to end up writing k plus 1, but I can't forget I already have a 2 there. And I do the same thing for the expression to the right hand side. That first k becomes a k plus 1. That second k becomes a k plus 1. There's already a 5, so I keep that. And I write my denominator of 2. Now I need to resolve or simplify where I can. K plus 1 actually turns into k plus 3. Then here to the right, I keep the k plus 1 factor, and then k plus 1 plus 5 actually turns into k plus 6, and my denominator stays as a 2. Next thing to notice here is that this part of the series matches exactly S sub k, which is defined above it. So we can rewrite S sub k as this shorter expression. So here, k times the quantity k plus 5 divided by 2. If I add that to the next term, I should come out to what I have equal here on the right hand side. First thing I want to do is notice that these are two fractions, and for me to add fractions I must have common denominator. So to do that, I'm going to make this denominator a 2, which means I multiply my denominator by 2, which means I also have to multiply this numerator by 2. Now I can rewrite this as k squared plus 5k, because I just distributed this k to both terms, plus 2 times k, or 2k, plus 6. Again, I did the same thing by distributing, and all this has a denominator of 2. And I'm not going to rewrite the other side, just put a dot there to show that that's, or an arrow here to show that that came down. Now I'm going to simplify the left hand side by combining like terms. K squared plus my 2k terms turn into 7k, because 5 plus 2 gives me 7. Rewrite my 6, and again divide by 2. Another arrow down showing that's coming down. And what I want to do now here is factor. My factors of 6 that add up to 7 have to be 6 and 1, and they're both going to be positive. So here I end up with a k plus 1 times a k plus 2. K plus 1 times a k plus 6. Let me rewrite that. Times k plus 6, because 1 times 6 is 6, and then 1 plus 6 is a 7, and all that's divided by 2. And now I will rewrite the right hand side where it is k plus 1 times the quantity k plus 6, again divided by 2. We see the left hand side matches the right hand side, so we have proved by induction this particular example. Thank you again for watching a video by Speller Tutorial Services. Please friend us on Facebook and also subscribe to our YouTube channel. And as always, thank you for watching.